Hello, welcome to this short course on Layers of Protection Analysis LOPA. In this short course you will learn, what is Layers of Protection Analysis LOPA, how LOPA works or what is the LOPA procedure, limitations of LOPA and benefits of LOPA, example of LOPA and some common LOPA terminology. Who this course is for? This course is for chemical process engineers, production operations engineers, and process safety engineers, facility operations staff, HSE officers or managers, students and professionals, and anyone else who has interest in this topic. Layers of Protection Analysis LOPA is a simplified form of risk assessment, and a powerful analytical tool for assessing the adequacy of layers of protection used to mitigate process risk. LOPA is a semi-quantitative risk assessment technique. LOPA uses order of magnitude categories for initiating event frequency, consequence severity, and the likelihood of failure of independent protection layers IPLs to approximate the risk of a scenario. LOPA is an analysis tool that typically builds on the information developed during a qualitative hazard evaluation, such as HAZOP or Process Hazard Analysis, PHA. Like many other hazard analysis methods, the primary purpose of LOPA is to determine if there are sufficient layers of protection against an accident scenario. LOPA procedure should generally include developing scenarios, identifying initiating event frequency, identifying associated IPLs, determining scenario frequency, making risk decisions and estimating consequence and severity. In other words, LOPA procedure can be elaborated as follows. Define and document risk acceptance criteria. Define the consequence and severity of the impact event usually taken from HAZOP or Process Hazard Analysis, PHA. Identify initiating events and their associated frequencies. Select initiating event. Identify IPLs and their associated probability of failure on demand, PFDs. Define any appropriate frequency modifiers such as probability of ignition and probability of personnel in the area, etc. Calculate intermediate event likelihood and compare to risk acceptance criteria. If risk acceptance criteria is not satisfied, then determine what safety instrumented functions SIF are needed and what safety integrity levels SIL are required. Some of the shortcomings of LOPA are as follows. Among these is the fact that each LOPA analysis is restricted to a single cause-consequence pair. When multiple causes can instigate the same consequence, multiple LOPA analyses must sometimes be done. LOPA likelihoods are broken down into orders of magnitude change, and exact probabilities are impossible to calculate unless a large amount of field data is available. The independent protection layers, IPLs, that protect against a specific scenario are also given probabilities of failure on demand, PFDs, that are broken down into orders of magnitude change. LOPA is a simplified approach and should not be applied to all scenarios. The amount of effort required to implement LOPA may be excessive for some risk-based decisions and is overly simplistic for other decisions. LOPA has many benefits that justify investment by the company. Some of the benefits of LOPA are given below. LOPA can improve the efficiency of hazard evaluation meetings by providing a tool to help reach risk judgments quicker. LOPA facilitates the determination of more precise cause-consequence pairs, and therefore improves scenario identification. LOPA provides a means of comparing risk from unit to unit or plant to plant, if the same approach is used throughout the company. LOPA provides more defensible comparative risk judgments than qualitative methods due to the more rigorous documentation and the specific values assigned to frequency and consequence aspects of the scenario. Let's look at this example. High vapor pressure liquid hydrocarbon or chemical is stored in a vessel. A level controller is installed to control the liquid level via inlet control valve. If the vessel is overfilled, chemical will be released through pressure safety valve, PSV, and will be contained in a dike. HAZOP indicated that level indicator controller, LIC, might fail, which results in overfilling the tank. If the dike fails, some liquid and/or vapor would escape from the dike. The presence of an ignition source near the tank is possible from time to time and personnel are in the area occasionally, which could result in a fatality. The operating company wants to determine if the existing facility satisfies their corporate risk criteria, or if any changes are required and if so how extensive they would need to be. Let's assume that the operator company decides to refer to the Table 1, LOPA worksheet, which is included in one of the later slides of this presentation. where probability of basic process control system loop failure is 0.1. Probability of dike failure is 0.01. And probability of ignition is 1. When we multiply these numbers, the probability of fire becomes 0.001 or 1 multiplied by 10 to the power of negative 3. In this table 1, the company has also specified the tolerable corporate risk target, which is 1 multiplied by 10 to the power of negative 4. This means that the corporate risk target for the fire is not met by factor 10. Let's assume again, if the probability of fatality is 2.5 multiplied by 10 to the power of negative 4, and the corporate maximum tolerable risk for fatal injury, according to table 1, is 1 multiplied by 10 to the power of negative 5. This means that the corporate risk target for fatality is not met by factor 25, because the corporate risk target for fatality is not met by factor 25. Therefore, a possible solution would be to install a separate high-level shutdown function. This safeguard is a safety instrumented function SIF with a safety integrity level 1 or SIL 1. SIL 1 typically consists of single sensor, single logic processor and single final element. Therefore, this safety instrumented function would achieve the required risk reduction factor acceptable to the company. Here is some common LOPA terminology for your reference. Also, here is table 1, LOPA worksheet example. The next 3 slides are included for your reference as well. That is it for this short course now. Please feel welcome to contact us at info@hjs-tech.com, should you have any comments or suggestions. You can also reach us if you want to inquire about remote engineering support for your projects. Thank you for watching.